Hello, this video is on day 2 of chapter 4, 4.1 and 4.2 lesson. For our opening activity today, we're just going to go ahead and do a review of what you did yesterday. So let's take a look at this function we have here, the degree. So remember that when it does not completely go through, but rather has a turning point at the x-axis, that is a repeated zero. And the degree is the number of zeros we have. So here we have 2, here's 1, here's 1, so 2, 3, 4. That's going to be a fourth degree polynomial. Our leading coefficient, here we just want to know, is it positive or negative? Both ends are up on an even degree polynomial, so that means it's going to be positive. Then how many zeros do we have and what are they? Remember, we have 4 zeros. We have a repeated 0 at x equals 0. So we have to write that one twice. Then we have a 0 at x equals 1 and x equals 3. Now we're looking at our end behavior. As x goes to negative infinity, f of x is going to positive infinity. And as x is going to infinity, f of x is going to infinity. Good. So today, as I said, we're going to be going over 4.1 and 4.2, our learning targets for the day. I can identify polynomial functions, graph polynomial functions using tables and end behaviors, add and subtract polynomials, as well as multiply polynomials. So this should be a review from our exploration yesterday, but just make sure that we're all on the same page for this. So for a function to be a polynomial, all exponents must be whole numbers and all coefficients must be real numbers. So remember, whole numbers are 0, 1, 2, 3, 4 to infinity, and real numbers can't be imaginary. And then this is a good reminder here. First degree polynomials are linear, second degree quadratic, third degree cubic, and fourth degree are quartic. And here's just a summary of what hopefully we found out in our exploration yesterday, that an odd degree polynomial that has a positive leading coefficient is going to have opposite end behaviors. And then remember when I mentioned like this starts with a positive slope. So that's how we can keep that straight. Or another way to think about it, it ends in the positive direction, going up. And then it flips for a negative odd degree polynomial. So it either starts with that negative slope or ends going in the negative direction. And then make sure we take note of those end behaviors too. For a positive, we have f of x goes to infinity as x goes to infinity, and as f of x goes to negative infinity, x goes to negative infinity. And again, those just flip for the negative. So as f of x goes to infinity, x goes to negative infinity. As f of x goes to negative infinity, x goes to infinity. And then here we're looking at even degree polynomials. So remember, with even degree, the end behaviors are going to be going in the same direction. If it's positive, they both go up. I think of a parabola when I think of even degree. And then there's going to be some stuff going on in the middle there. So an even degree opens up, negative even degree opens down. And then here, as f of x goes to infinity, x goes to negative infinity. As f of x goes to infinity, x goes to infinity. Here, as f of x goes to negative infinity, x goes to negative infinity. And f of x goes to negative infinity as x goes to positive infinity. So I want you to take some time, review what we just looked at here with even, odd, and then positive and negative coefficients, and sketch the graph and then describe the end behavior. So as f of x goes to positive or negative, as x goes to positive or negative infinity. So pause the video here, and I want you to do a rough sketch of these functions. So we take a look at the leading coefficient. We have a negative leading coefficient, and it is a fourth degree. So it's even. We know they're both going to be going in the same direction, and it's negative. So we know they're both going to be going down, and it should have 4 zeros. So it's either going to have 2 repeated zeros, or 4 regular zeros. We don't need to know the exact zeros for this. This will kind of be very hard to figure out at this point. You don't know how to do that. So we're just going to do a rough sketch. Again, just a rough sketch. We need both ends to be negative. So I'm going to do 2 repeated zeros. It would look something like that. And then I'm not sure where. Something like that. Right? It's even, so they're both going in the same direction. It's negative. And then we need to know the end behavior. So f of x goes to negative infinity as x goes to negative infinity. And f of x goes to negative infinity as x goes to infinity. This one we have a positive leading coefficient and an odd degree polynomial. So it's positive, so we know we're going to start with a positive slope, something like that, and it's odd, so we know those end behaviors are going to be opposite, and this is honestly all we need for our sketch of a graph. We just need to know that. And it's going to have 3 zeros, so we can do 1 repeated or 3 regular zeros, so it crosses the x-axis 1, 2, 3 times, something like that is what we need. Now, as f of x goes to negative infinity, as x goes to negative infinity, and as x goes to positive infinity, we have f of x goes to positive infinity. All right, that should be a review from our exploration from yesterday. Now we're going to do that given a graph. So describe the leading coefficient. Is it going to be positive or negative in the degree of the polynomial? I like to start with the degree. So we see that the ends are in negative, going in, opposite directions. So we know that the degree is going to be odd. And then is that leading coefficient positive or negative? We start with a negative slope, or it ends going in the negative direction. So the leading coefficient is negative. And then can we figure out what degree this is? So we know it's odd because it goes in opposite directions. But to figure out what the actual degree is, remember we look at how many zeros there are. So here we see it crosses the x-axis 1, 2, 3 times. So it is a third degree. Perfect. All right, now again, pause the video and go ahead and do these. So the directions say determine if it is a polynomial function. If so, write it in standard form. State the degree, the type, and the leading coefficient. So what we're looking for here, remember the definition of a polynomial. All exponents need to be whole numbers and all coefficients must be real numbers. So use that definition to decide if it is a polynomial. If it's not, go ahead and circle no. And then if it is, write it in standard form, find the degree, find the type, and the leading coefficient. So go ahead, pause the video to do that. Okay, so let's look at this, take a look at this first one. We have a positive leading coefficient. First of all, is this a polynomial? Are all of my exponents real numbers? And what else did it say? All exponents must be whole numbers and coefficients must be real numbers. Excuse me. All my coefficients are real numbers and all of my exponents are whole numbers. So yes, we can go ahead. This is a polynomial. I want to write it in standard form. So standard form is writing it from highest degree and then in decreasing order. So I would have negative 3x to the fourth. My next highest is plus 2x squared, then plus 6x plus 1 equals f of x. What is my degree? That's going to be the highest power. My degree here is 4. The type, so this we're looking, is it linear, quadratic? Here the degree is 4, so it's going to be quartic. Again, if you don't remember, rewind the video, go back to that slide with the definition on it. And my leading coefficient is, I'm looking for negative. All right, number 2 here, we have negative 3/7 x to the third plus x, or 7 over x, excuse me, minus 3. So again, are all my exponents whole numbers, and are all coefficients real numbers? So we see the coefficients are real numbers, so then we look at our exponents. This might throw you off. If you remember our exponents rules, this is equivalent to 7x to the negative 1, and negative 1 is not a whole number, so this is not a polynomial. And then these, let's just look if it is or is not a polynomial. I think we know how to do the standard form, degree, and type. So is square root of 15 a real number? Yes, it is. And this is just to the first degree. So yes, this is a polynomial. And let's take a look. Is square root of 3 a real number? It is real. It's just irrational, but it's still a real number. And all my exponents are whole numbers. So yes, that is a polynomial. Find the sum or difference. So here we're adding, so we're going to find the sum. The easiest way that I do this is I distribute whatever this sign is. So I'm going to distribute that addition sign and then rewrite. I have 3a plus 8 minus 2a cubed plus 4a cubed minus 6a, since this is addition, we don't change any signs, right? Plus 2. Now I'm going to look for combined like terms. I have cubed there. I have to the first here. And then, I'm sorry, they're testing the fire alarms. So I'm going to combine my like terms. I have 4a cubed minus 2a cubed gives me 2a cubed. Now my next, I have no squared, so I go on a to the first, which is negative 6a plus 3a gives me negative 3a. And then moving on, I have 8 and 2 plus 10. Right, that's my final answer there. Here I am subtracting, so I'm going to distribute that negative sign, and then this is where we need to be careful. We have 6 minus 3x to the fourth plus 5x minus 3x to the fourth. Now we have a negative times a negative gives us a positive plus 6x minus 3. Now again, go ahead and combine our like terms. So I'm just going to use some color coding here to make it a little bit easier for me. All right, so I combine my x to the fourth. I have negative 3x to the fourth minus 3x to the fourth gives me negative 6x to the fourth. My next is x, so 5x plus 6x gives me 11x. And then I have 6 minus 3 gives me 3. Now I'm going to find the product. I think you guys should have seen foiling in Algebra 1, so this should be a good reminder. And we also talked about it a little bit when we were factoring. So let's go ahead and remember first, outer, inner, and last. Oh, I kind of did that off. First, outer, inner, and then last here. That's what the FOIL stands for. So I do 6b times 3b gives me 18b cubed. Now I have 6b times 4 gives me 24b. Here I have 8 times 3b plus, right? The things are positive, so 8 times 3 is 24b. 8 times 4 is 32. Now again, I combine like terms. I have 18b cubed plus 48b plus 32. If you haven't already, pause and try and do these on your own. I'm going to keep going. So again, we have to distribute to all terms. Here we see we're factoring polynomials with 3 terms. So that 6 has to go to all 3 terms. Then we move on to the 3 and distribute that to all 3 terms. And then lastly, we would go ahead and distribute that 6. All right, so this one's going to get kind of messy. We have 6n squared times 3n squared gives me 6 times 3 is 18. And n squared times n squared is n to the 4th. Now I go 6n squared times negative 2n gives me negative 12n to the 3rd. Now I'm at 6n squared times 4 gives me plus 24n squared. Now I move on to that 3n. 3n times 3n squared gives me 9n cubed. 3n times negative 2n is going to give me negative 6n squared. And then I have 3n times 4 gives me plus 3 times 4 is 12n. Now I move on to that negative 6, and I have negative 6 times 3n squared gives me negative 18n squared. Negative 6 times negative 2n gives me a positive 12n. Now I have a negative 6 times positive 4 gives me a negative 24. So now I'm going to go ahead use my colors to combine like terms. I only have 1 to the 4th, negative 12n to the 3rd, plus 9n to the 3rd. I'm looking for my squares, and then looking for my solo n's. And then I want to combine all of those. So 18n to the 4th stays. Next, I look at my cubes. Negative 12n plus 9n is going to give me negative 3n cubed. And then I'm looking at my squares. 24 minus 6 is going to give me 18. Oh, and then I have a negative 18. I forgot that. So I'm at 18n squared minus 18. That's going to be 0. So my n's squared are going to all cancel out. Now I'm looking at n. I have 12n and 12n. Gives me 24n. And then lastly, that 24. All right, so that is our answer there. Now we have to remember that when a quantity is squared, we have, this can be written as 3x squared minus 2 times 3x squared minus 2. A lot of times students want to distribute that 2 in. We can't do that. This whole quantity is squared. So we rewrite like this, and then FOIL simply 3x squared times 3x squared, 9x to the 4th. Then I have 3x squared minus 2 is negative 6x squared. I move on to that negative 2. Negative 6x squared, negative 2 times negative 2 is positive 4. Again, combine like terms. There's my answer. Last one here, same thing, we cannot distribute that cubed, so we have x minus 2 times x minus 2 times x minus 2. So these get kind of tricky, so what I do is I FOIL this one term, then multiply by that last term. So I have x squared, right, minus 2x plus 4. If I simplify that, I have x squared minus 4x plus 4. And then don't forget, we have this end term here we need to multiply yet. So we have x squared times x gives me x cubed. X squared times negative 2 gives me negative 2x squared. Negative 4x times x gives me negative 4x squared. Negative 4x times negative 2 is plus 8x. And then 4 times x is plus 4x. And 4 times negative 2 gives me negative 8. Again, combine your like terms. X cubed negative 6x squared plus 12x minus 8. And that's all we have for today's lesson. So be sure you do the 4.1, 4.2 worksheet and the 4.1, 4.2 formative, both found on today's Schoology page. Again, as always, reach out if you have any questions, and we are happy to answer them. Have a great day.